Hey everyone, this week we are going over Barry Bonds' 2004 season. I thought it was very fitting since Hall of Fame voting is about to come to a conclusion. Hopefully he gets in, he deserves it. We're going to see how feared he was in terms of pitchers throwing to him through animation in R. So let's get to it. URL right here is where we'll start. We'll grab this URL exactly. You can go through it by just, searching Barry Bonds baseball reference and then finding his game logs from 2004. As you can see, there's already code written. I kind of did this to make it a little bit faster when I was going through this earlier. It was going to be about a 30-40 minute video, and I wanted to reduce that. So essentially, I'll just go through each bit of code and explain what's happening, what exactly is the code going through. So again, we'll create basically a URL instance calling Bonds URL to pull Barry Bonds' game logs from 2004. And then to install packages that allow you to manipulate data, so on and so forth. We will do install packages. Again, you only have to call this once to install packages, and then after that, if you want to call certain things, you will use library. So we'll call library, plier, call library, tidyverse. We'll create a list, then we'll call rvest. In this bit of code, we again download Google Chrome if you haven't already, and then download the extension selector gadget. This is where I got the XPath from, and then this is where I got the hyperlink reference. Essentially, this pulls from Barry Bonds' game logs table and selects the hyperlinks in that table. So we'll run through all of this, and then we want to create a data frame and then change the column name so that way we can manipulate it later. So we'll run through all this, and then we'll view it. So we can just type view, let's say URL ID. You can see it says boxes or teams, and we just want boxes. So a quick and easy way to do that is, again, URL ID, the piping operator, it's a continuation filter, and then the grepel essentially means that we want to keep rows in the column URLs that contain boxes. So we'll run that. And again, we can go down here and just type view URL ID. And again, it's just boxes, so on and so forth. Then we want to create the web page for each box score to pull Barry Bonds' plate appearances. So we'll do a paste 0, which essentially means you're taking the last part of the URL and pasting it with baseballreference.com to create a full URL. And I'll show you. This is a full URL. So this is the Giants versus Astros 2004 April 5th game box score. Then I won't run through this code because it will take a lot of time. I already have it loaded, however, but essentially we're creating a list, and then we're going through each row of the URL ID. And for the double brackets, essentially means each item in the list, and then the single bracket is for each row instance of the column box scores in this case. So essentially it's going through each box score and getting the comment of the text and then collapsing. So baseball reference, again, goes through. If it's not the first table that appears on baseball reference, it's listed under as a comment. And then, so what you have to do to access that is do an XPath comment, HTML text, and then paste collapse to get rid of that comment so you can scrape that table that you are looking for. So in this case, it's play-by-play. Again, we're extracting a specific node. So we will do play-by-play, and then we want to pull a table. Then for each element in the list, we want to pull the date. And on each box score site, there is the game date that's listed towards the top. And this is the CSS for the game date. So scorebox underscore meta div nth child 1. Again, download Google Chrome, use Selector Gadget to achieve that, and just click on the game date. It's towards the top. And then we will do a system sleep. That way your code doesn't stop or your code times out, because it does take a while to pull box scores from every game that bonds appeared in. I won't run it because, like I said, it will take a while, but it's already in there. And then this line of code, game logs ldply, essentially takes that list and converts it to a data frame. This is ldply is an applier package that we called earlier. And we'll run that, and then we want to subset data to only Barry Bonds' plate appearances. So how we achieve that is we'll install stringer, call stringer. I think it's already in the tidyverse package, but just to be safe, call it again if you need to. And what we'll do is we'll trim the batter strings. Essentially what that means is we will pull any hidden characters that may be in the string. That way we do have a way to properly subset data. So how we subset it is, we do another grepel, and we'll pull every row instance of bonds from the game logs batter. So again, how we do that, call the data frame game logs, and then in square brackets we want to pull every row that contains bonds, and that's how we call it, is that comma. So that comma out and the data before the column means we want to pull all the rows. If we put something after, that means we want to reference the columns. So again, we'll run that, and then we'll format the date column. So if we look into bonds PA, so we'll view it, we can see that it's listed by day of the week, month, day, full year. And again, we got all the data of Barry Bonds. And so how we do that is we'll convert it from formatting from, again, day of the week, month, day, year, to just month, day, year. And how we do that is the %A essentially means the full day of the week. So obviously it's spelled out Monday, so on and so forth. And then %B is the full month, which is April. And then D is just the day number. And then capital Y is the full day year. So we'll format that, and then we'll convert it to a date. And then we'll see it switched now to the correct day and year. And then again in the stringer package, what we're going to do is pull from the play description to get the exact result. So we'll pull the first word. Again, it may not look pretty at first, but we will adjust it accordingly. So there might be colons or intentional walk. It just says intentional. And what we'll do is, again, to kind of look up things in R, you can do question mark, and in this case it's a regular expression, and we'll look it up in regular expressions R, and this tells you exactly what you want to pull. So if we look closely, punctuation characters, we want to substitute punctuation characters with a space. We want to get rid of them essentially. There's more than one way of doing it. I just did G sub, but if you are curious about a package, a specific function in a package, just do question mark whatever you're looking at. Or if you want to do a search of all instances, do a double question mark, and you'll arrive at the same result. So remove all punctuation, and then again we'll see that some of these strings aren't complete. So essentially we'll do a string replace also in the stringer package, and we'll pull from the result, and essentially we will replace each instance with that instance. Ground specifically, so there might be like ground rule double, or ground ball double play. So to prevent that from pulling or incorrectly changing ground rule to ground out, how we do that is we'll do a double/B on both sides, which essentially is an escape character. That essentially means that we only want instances where exactly ground is stated. So that way, if it says ground rule double, it won't say ground out rule double. Instead, it'll just say ground out or ground rule double, so on and so forth. So again, we'll replace those strings. And then again, we'll trim the strings just in case if there's any hidden characters. And then we'll look at each results. So we'll see double walk, home run, ground out, fall out, single, fly ball, strikeout, pop fly, line out. And then there's various strings that you don't necessarily need. So like reached is assuming it's reached on an error. Fielders, assuming it's fielder's choice. And then we want to remove those instances that don't necessarily, so like, if there's another player name or if there's a wild pitch or passed ball. So we'll run these two first. Again, it's simple string replace that I just talked about. Then this one, we're essentially doing a grepel, but we want to do the opposite of it. So instead of keeping those rows, we want to remove those rows. So to remove that, we'll do an exclamation point in front of the grepel. And then this tall line between it means we want to remove wild or snow, or essentially that tall line means or. And again, in front of the comment indicate rows. So we'll run that. Now we can see the count of each result. So essentially we'll do, again, bonds PAs, group by result. dplyr is giving me difficulties, so how you call a specific function in a specific package, you will say the package name, 2 colons, and then the function name. So plier, summarize, and then we create a new column that just says count results. So we'll run this. We can see bonds of 2004, 29 doubles, fielder's choice, 55 fly ball outs, 10 fall outs, 83 ground outs, 9 hit by pitches, 45 home runs, 19 line outs, 25 pop flies, 6 reach on and errors, 60 singles, 40 strikeouts, 3 triples, and 232 walks. If you add that up, that equals 617, the amount of plate appearances he had in 2004. So then to continue, we'll convert our results into factors with levels. That way it's easier to plot. So run this. And this is where we'll get our vertical bar chart, and we will animate it so you can kind of see some cool stuff. So what we'll do is, install gganimate if you haven't already, and then call it with library. And then going through each bit of code, we'll do a ggplot, and this time we're calling the data of bonds PAs, but we're going to keep rows where first base is unoccupied and there's at least one runner on base, the aesthetic, and then our X value, we're going to do a reorder where we'll do results and we'll do the length of the result as the function. Essentially, what this does is it will order the bar chart to go from smallest occurrence to largest occurrence, and then the fill, which with color, will show you each result's color. And then we want a bar chart, so we'll do geom bar, the aesthetic, and then the Y with the double periods aside from each count. So we're just going to count each result. So this is useful in doing the animation plots. Then we want to display each occurrence. So again, geom text, stat count, and label count. And then the vjust essentially is the vertical adjustment. So that way it's not, hidden inside of bar. You can hardly see it, so it's just -1 above the bar. Then we'll do the percentage. Again, I did a poll on Twitter. I asked you guys how many, with runners, at least one runner on and first base unoccupied, what percentage of times Barry Bonds was walked? And the choices were less than 40%, 41 to 60%, 61 to 80%, and above 80%. Most of you voted 61 to 80%, and we'll find out here shortly. But essentially what we'll do is we're doing a pace 0, and essentially what we're doing is just getting the percentage. We'll do a round by 1 decimal point, and we'll do the count of each result divided by the total results, multiply it by 100, and then get a percentage. And then that will be above the occurrences. And then We'll call our X label result, and then call a GG title, which is a label Barry Bonds play appearance results with minimum 1 runner on base and first base open. And the subtitle can be 2004 season. This is where the gganimate comes in. So transition states that are ordered from smallest to largest occurrence result. Each state will be like a static plot, essentially. So again, we'll do the reorder again. That way it goes from smallest to largest. And then the transition in each state will be a 1, essentially 1 second. Is the way. And then shadow mark essentially is where you can allow each plot to be layered upon the next. So like the smallest occurrence will remain there, and then the next occurrence will appear, so on and so forth. Then we don't want a legend, so we can say legend position none. We'll get rid of it. And then this is where we'll do our animation. Install GIFski, library GIFski, to create a GIF or GIF. I think it's pronounced GIF, to be honest with you, but either or is fine with me. And essentially what we'll do is animate. We'll call this in an animation, so I called it Bonds Anim. And then this is the amount of frames you want, and then the frames per second, and then this is just for visual to be able to see. And then this is what you want to render, so we want to render as a GIF, and we'll see the results. So we'll call the library gganimate first. And then, like dplyr, the plus signs in ggplot essentially mean continuates the code. So we'll run all this. And then we'll create a animation. We will render our plot, so we'll call GIFski, and then we'll animate with the animation, 30 frames, 1 frame per second, and then we'll render it in Bonds.gif. It renders, loads the frames, and it is done loading. So in instances where Bonds had a runner on base and first base was not occupied, he hit 1 double, 1 fly ball out, 1 foul out, 1 line out, 1 pop fly, 1 time reached on an error, 1 triple, 2 strikeouts, 3 singles, 5 home runs, 7 groundouts, and 84 walks. So if you voted between 61 and 80% on my Twitter poll, you were correct. Holy cow, pitchers feared him. And if you look at any other situation, feel free to look into it, but he was walked a lot. Continuing on, we will essentially get the cumulative results by each value by each day. So create a value that says 1, and then we'll create a Bonds cumulative data frame. We'll go through Bonds PA, piping operator. And this is where we'll do complete nesting result fill list value equals 0. Essentially that means we're going to go through each result and each day, and essentially what it'll do is get every grouping of every result on each day. So, you know, if Bonds went 1 for 4 with a double and let's say 3 flyouts on April 7th, it will still say 1 double, 3 flyouts, but also say, you know, 0 strikeouts, 0 walks, so on and so forth. And then we'll arrange it by date, so that way it goes from first game of the season, last game of the season. And then it will group by the result, and then we'll do a mutate, create a new column called CSUM, which is the cumulative sum of the value. So we'll run these, then create another animation. And what we'll do is do another animation where ggplot. So ggplot AES x equals result. This time we'll do a geom call, which is essentially the same as a geom bar. And we'll do y equals the cumulative sum. And then this is where we'll do labels, no labels, but we'll have a title, Barry Bonds, PRA, results by date in 2004, and then the subtitle, the closest date comes in. That essentially means what day it was with the animation plots. So, you know, April 5th, April 7th, so on and so forth. And then we'll do a coordinate flip, so we'll flip the coordinates so you can see the animation a little bit better, side to side rather than up and down. Transition states, again, will transition by date. The length will be 2, and then the state length will be 1, essentially, where the states essentially creates a static plot of each game day result. And then ease AES is just a way of, visually aesthetically seeing it. So it's a linear one where, the bar will continually go up. And then to create a video, we'll install packages AV and then write a library called AV. And we'll run this. It takes a little bit more time because, again, it's 500 frames. We're running 10 frames per second. And so we'll render in an MP4 file to make it easier to see. So we'll run all that stuff, and I will show you shortly the plot of the video. So this plot that renders will show each PA result by date in 2004. And again, if it goes up quickly, that just means more values are being added. So you can see over time, Barry Bonds was walked a lot in the 2004 season. And we'll go over each instance. Groundouts were getting up there, but walks are the main thing. And you can see that, colors are sorted over there. Each result type going through August, still going up there. Again, he had 232 walks. That includes intentional walks. So he had 120 intentional walks. Be sure to like and subscribe. Tune in again. We will do something really cool with Barry Bonds and his 2004 season and any other season with any other Major League player. So as long as there's specific data available, tune in again. Again, like and subscribe. Feel free to ask questions. I want to do this for you, everyone. Help you learn R, help you learn code with baseball data.